So we're going to start with a whole new note, and I think it's a good idea in your notability. All of this stuff from first semester, you can take that and put it into a different folder if you want. You could even delete it if you want, or put it somewhere else. You don't necessarily need that. I'm going to leave it there because it's not that much stuff for me. But if you guys like to have less things in your folders, again, when we take our second semester stuff is only going to cover from today forward, and all that stuff is accessible through our calendar anyways. So I'm going to start an entirely new note. And in fact, before I even do anything, I'm going to go back and rename that note into our log/exponential functions. Oops. I remember I can't do a slash. That's my problem. All right, so I'm going to do log-exponential functions. All right, so I'm going to talk about what a log and exponential function is in just a few moments. But before we do that, the first thing I want to start off with is inverse functions. So when we first began talking about functions, I had these crazy looking function machines, you might remember. So, I had something that looked like this. And we might have something in there. So f of x is equal to, I'll make it simple. How about 3x? Okay, so that would be our function. And we drop stuff into the function. So we might take the number 5, drop it into the function. That's our input or our domain. And it's going to spit out an output. So it would spit out 15. That would be the number that's in the range. So this would be things that we did quite a bit first semester. An inverse function is then another function that is going to undo the first function. So for example, we take that 5, we plug it in, drop it into the first function, it spits out 15. But now 15 is going to drop into another function, which I'm going to denote with this little -1. That is called the inverse of f. And I want to undo multiplying by 3. Well, to do that, I divide by 3, right? That's the opposite or inverse operation of multiplying by 3. So 15 drops in there. 15 divided by 3 is 5. And I'm back to where I started. That is the whole concept of what an inverse function does. So again, for an inverse, you take any input, I just made up the 5, drop it in to the function, it spits something out. If that goes into its inverse, it undoes the process and puts you right back to where you started. That's what an inverse function does. All right, so we're going to come up with a couple of inverse functions. So for example, let's say we had a function that f of x was equal to 8x to the 5th. All right, we want to find its inverse. So again, it's denoted with that little -1 there. That means the inverse. So the inverse of f. All right, so f of x is 8x to the 5th. Well, here's how I think your brain would process that. Think about if you plugged a number into this function. All right, well, if you plug a number into that function, the first thing you would do is go to the 5th power. And then the second thing you would do is take that number and multiply by 8. So we want a function that undoes that process, and we want it to undo it in the reverse order. So what we want to do then for its inverse here is, instead of multiplying by 8, we want to divide by 8. And then instead of taking to the 5th power, we could do the 5th root. That's how we come up with our inverse. So we take our number, we divide by 8, and then take the 5th root. And that is our inverse function. All right, so again, we're trying to come up with a function that undoes the original. So think about what you would do if you had an input. If I put a number in for x, I would do it to the 5th power and then multiply by 8. So I want to undo that in the reverse order. I want to put a number in, divide by 8, and then take the 5th root of that. All right, let's do another example. Let's say we had f of x is equal to x to the 1/3 minus 9. Okay, we want to find its inverse. We want to find the inverse of f. All right, so let's think about what we would do if we plugged a number into the original function. The first thing we would do is we would take to the 1/3 power, or that's the 3rd root, remember. Okay, so the 1/3 power. And then the second thing is we would subtract 9. So to do that in reverse order, we would add 9 and then cube it, meaning take it to the 3rd power, because 3 times 1/3 would be 1. So we're undoing that like cube root. So that's how we find our inverse. We're going to take our x, we're going to add 9, and then cube it. All right, we still hanging in there? I'll do another one here.
Mr. O'Connor, quick question.
Yeah.
Regarding that one, what if like the x minus 9 is internal and like the power of 3 is like external? Would we still like do like add 9 and then cube it? So like say if it was x minus 9 parentheses 1/3.
Like this?
Yeah.
Yeah, so then the orders would be different because so to find the inverse of this guy, when you plug a number in, the first thing you would do is subtract 9 and then take to the 1/3 power. So to undo that, you have to undo it in reverse order. So we first would cube and then add 9. So it would change the order in that case.
Okay, so instead of it being like 9 to the 3rd power,
it would be the inverse would be x cubed plus 9, like that. You would cube it first.
Oh, okay, so it would become external.
Yep. Yeah, good question, Maria. All right, let's do another one. So this is good. I think you guys from that question seem to be getting it. So that's good news. All right, let's take f of x is equal to the square root of x plus 9. So this would be similar, I think, to what was just asked. So we wanted to find its inverse. All right, well, think about what we would do if you plugged a number into that function. The first thing we would do is add 9, and then we would take the square root. So we want to undo those things in reverse order. So if we would add 9 and then take the square root, the first thing we would do is square to undo the square root, and then subtract 9. That would be its inverse. Now, there is another algebraic way. If you're having trouble doing that in your head, there is an algebraic way. You don't have to do both ways. You don't. But what you could do is, f of x is like a y equals. And so one way to solve it algebraically would be is you switch the x's and y's here. So I switch the x and y and write that as x equals the square root of y plus 9. Okay, so again, I switch x and y. And then I'm going to solve for y. So if I want to solve this thing for y, I would square both sides. So I get x squared is equal to y plus 9. And then I would subtract the 9 over. And look at that, it's the same thing. So you could use that algebraic method where you switch the x's and y's and then solve it for y. And that would work for any of these. All right, so that's what inverse functions do. Now, here's why I introduced inverse functions when our topic here is log and exponential functions. All right, I'm going to write some stuff. You don't need to write this down because I'm going to erase it in just a second. But if you had something like 2 to the x is equal to 8, that problem we could do in our head, like 2 to what power is 8? Well, that means 2 to the third is 8, so x is 3, because 2 times 2 is 4, times 2 is 8. All right, so we could solve that one. That's a really nice number. If I had 2 to the x is equal to 32, it might take a little work, but we would do that in our head. Like 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that means that like x is to the fifth. But if I had 2 to the x is equal to 20, that's ugly because x is not an integer. I can't take 2 to a power and get 20. So that's a problem. So I need to undo this exponential idea. Okay, just like if I had 5 to the x is equal to 25, well, x is 2 because 5 squared is 25. But if I had 5 to the x is equal to 35, well, now that's a harder problem because x is not an integer. So I need to undo that 5 to the x thing. So the way we undo that is called a log or logarithmic function. A logarithmic function is the inverse of an exponential function. It undoes it. And so that's a real quick introduction, but what I want to show you is how we can write in exponential and log form. All right, so that is EXP. I know that looks like a poorly spelled word there. So write in exponential or log form. For example, I think I had 2 to the x was equal to 20, right? That is in exponential form. I can write that in log form. Here's what we do. We take the log is an operation. Okay, it's like multiplying or dividing. We take the log base 2 of both sides because log base 2 and the 2 to a power, those operations are inverses. They cancel each other out. And so we get x equals log base 2 of 20. This, believe it or not, is a number, and that would be your answer for x. Okay, it's written in log form from exponential form.
Okay, so log 2, we just cancel. So then what if we have like log 2, 4?
All right, good question. You said log, all right,
Like log 2, 4 equals log 220.
oh, okay, let me start with this. All right, let's say we had 4 to the x is equal to 30, okay? Now, what we want to do is we want to get rid of or undo the 4 to the x. So that means we are taking log base 4 of both sides. So was your question, what if these were different logs on both sides? Or let me finish this one and maybe I'm trying to get your question, but I'm not sure I understood it correctly. So if I had log base 4 of 4, those would cancel and I would get x equals log base 4 of 30.
Okay, so that answered one of my questions. And then the one that I was trying to ask, so what if it's like log base 2, 4 x equals log base 2, 20? Because you wouldn't be able to cancel.
Like this?
Yeah.
Yeah. You're getting ahead of it, but it's a really good question. You actually, if you have log base 2 on both sides, you can take 2 to the power of both sides and those cancel and you just get 4x equals 20 or x equals 5.
So like if we had that exact same problem, but like with an exponent, we could do that as well.
Yep, exactly. Yeah, you're getting ahead of us, but yes, you are totally correct. All right, now, so what some students find helpful is just to kind of memorize a pattern of where things go. Like I started with 2 to the x is equal to 20. Well, the pattern is that this, whatever that exponent is, that comes down and that's your x, that's whatever is equal to. This number becomes your base. And this is what you're taking the log of. And so you can just kind of skip that way. And obviously you get the same answer, just following the pattern of how they move. So on the right side, like we had 4 to the x is equal to 30. So I'm just going to follow the pattern to rewrite that. So the x comes down, the 4 becomes our base. And so I get x equals log base 4 of 30. And when that's written, this number is a subscript, okay? The base is a subscript, means it's written smaller and it's below the line. And all of these things are the same size and they're all written on the same line. All right, I know I'm throwing a lot at you here, but I want to take one the other way as well. If we had, let's say we had log base 6x to the 4x minus 3 is equal to 10. All right, that is an ugly looking problem. But it's in log form. If I want to write this in exponential form, I could pattern wise, this number stays, this moves over, and this moves up. So that in exponential form would be 4x minus 3 is equal to 6x to the 10th power. All right, let me give you another example. If we had log base x plus 1 of 7 is equal to 3. So looking at the one above it, let's try and follow the same pattern to write it in exponential form. So the 7 stays, that's equal to the x plus 1 moves over and the 3 moves up. So it is x plus 1 to the third power. So this idea of writing back and forth from log form to exponential form, we're going to practice a little bit. Do you guys have questions on those last two that we just did? All right, why don't we go over the class kick together? So as I was bouncing in and out of your class kicks, it looks like you guys were doing okay, but some of you were hesitant, I think, and I just really would encourage you guys, just give it a try. And you're going to make mistakes at the beginning, believe me, when we're doing these. But I think the more that you do it, the more you practice, you're all going to be able to do this at some point. So for the first one, if I were to plug, we're trying to find the inverse. If I were to plug a number into here, I first would subtract 8 and then to the 1/3 power. So I first would subtract 8, and then second I would do to the 1/3 power. Okay, so for the inverse then, the first thing I have to do for the inverse is I have to undo this one. I'm going to go to the third power, and then I have to undo subtracting 8, and that's going to be to add 8. So I'm going to take my x to the third power and then add 8. So that would be our inverse. All right, for the second one, if you were to plug a number into here, first thing you would do is the fourth power and then divide by 3. So I want to multiply by 3 and then take the fourth root. So that would be our inverse. So I didn't write out the steps on that one, but I can if you want me to. Please make sure you just speak up.
Can you please?
Yeah. So again, if I plug the number into here, the first thing I would do is I would take to the fourth power. And then the second thing I would do is I would divide by 3. So I want to do the opposite of those in the opposite order. So first thing to undo dividing by 3, I would multiply by 3. And then to undo the fourth power, I take the fourth root. Okay, or I could do the 1/4 power, either way. So when I take my number and I multiply by 3, it gives me 3x. And then when I take the fourth root, that's the fourth root of 3x. That's how I got my answer. Okay, and again, you can always use the algebraic method, which I'll do for this last one here. Okay, and I'm going to switch the x's and y's and write that as x equals 6y to the third. So I switch the x and y's and then solve for y. So the first thing I would do is divide by 6 and then take the cube root. And that is our inverse. It's the cube root of x over 6. Or thinking that through, if I plug the number into here, I would cube it. and then multiply by 6. So to undo that, I would divide by 6 and then take the cube root. All right, any questions on the first slide before I go to the next one? All right, so for the next one, we're going to write in exponential form. So when we do that, that stays, that moves over, that moves up. So we get x equals x plus 2 to the 3x plus 1 power. And I'm going to follow the same pattern for the next one. The 5 stays, the x plus 2 moves over, and the 3/2 becomes our exponent. So we get 5 equals x plus 2 to the 3/2. All right, the last one, I didn't really address this, and some people got it, so you've seen that before. Now some of you have not. ln. ln is short for natural log, and it actually means this. It means log base e. So ln means log base e. So you could rewrite that, and I would suggest, especially early, just rewriting it as log base e of 3x minus 2 is equal to 1/2. And now it looks just like the problem above it. So I'll leave the 3x minus 2 on the left side. The e moves over, the 1/2 moves up, and that would be our answer. Okay, any questions on those?